Hey everyone, welcome back to the channel. Today I've got something mind-blowing to talk about: multiverse encryption. Imagine if encryption wasn't based on complex mathematics but on the very structure of existence itself. Crazy, right? Let's dive in. First off, what is multiverse encryption? It's a system that encodes information within the simulated configurations of a universe. It relies on a specific set of initial constants and space-time coordinates. Think of it as the DNA sequence of the universe, where emergent properties like a DNA strand or crystal formation become the key. Now, cracking this code is theoretically possible, but there's a huge catch. You'd need to simulate all possible universes to find the right one. And you're bound by the resources of your own universe to solve a problem that spans across a multiverse. Tall order, right? So, how does this encryption actually work? It all starts with universal constants. The system picks a unique set of initial constants like the gravitational constant, speed of light, and Planck constant to define the simulation's rules. Next, a precise portion of space-time at a specific coordinate and moment encodes the data. The simulation runs until specific emergent phenomena appear. These features represent the encrypted data. Here's the core idea. Deterministic physical laws mean that starting with the exact constants and conditions will always recreate the emergent result. Without them, brute forcing becomes a search across a multiverse. Now let's talk about why it's crackable in theory. To crack the encryption, you'd need to simulate every possible universe, adjust the constants, simulate the evolution of space-time configurations, and detect when the desired emergent feature appears. Sounds simple, right? Not so fast. The real challenge lies in resource constraints. Simulating even one universe demands astronomical computational power. Doing this for a near infinite set of configurations is unfeasible with the resources of a single universe. And here's the kicker: recreating Planck-scale configurations requires perfect accuracy. Any deviation destroys the result, so you can crack it if you have access to the resources of a multiverse. But within the constraints of a single universe, good luck with that. Let's look at some applications of this ultimate encryption. Imagine unbreakable data storage. Information could be encrypted as the DNA of an individual in a simulated alien universe. Only someone who can recreate the exact universe can access the data. Ultra-secure communication. Messages encoded as specific emergent features in a simulated spacetime. Decrypting would require knowing the exact simulation setup. How about digital archaeology? Encrypt historical data as a simulated civilization. The emergent features of their behavior become the key. But here's the kicker. Cracking this encryption within a single universe is practically impossible. The resource constraints are immense. Your universe provides finite computational power and matter. And the complexity? Each additional constant or parameter compounds the simulation's complexity exponentially. Running even one full simulation may take longer than the lifespan of your universe. With current technology, cracking multiverse encryption is way beyond our reach. Analog systems might be useful for approximating smaller configurations, but they're limited in scale. Quantum computers? Forget it. Alien quantum effects may differ, breaking our assumptions. And multiversal simulation? That requires infinite computational power, paradoxical within a single universe. So to wrap it up, this ultimate multiverse encryption makes the laws of the universe the ultimate lock. While theoretically crackable by searching all possible configurations across a multiverse, the resource constraints of a single universe make this task practically impossible. It's the perfect blend of irony and security. The key exists, but you'll never have the resources to turn it. Thanks for tuning in. If you enjoyed this deep dive into multiverse encryption, don't forget to like, subscribe, and hit that notification bell for more mind-bending content. Until next time, stay curious.